चलो, so axis का we are doing numericals, थोड़ा लेंदी रहेगा, but understand questions and all. A circular coil having 100 turns of wire of radius this much lies in xy plane with the center at the origin of the coordinates. Find the magnetic field at this point when the coil carries a current of this much. So what is saying? Is x-axis, z-axis, and y-axis. Something. Y-axis is coming towards you. A circular coil is there, which is placed at this origin, center में. इधर से which coordinate this is? Tell me. 0, 0, 20 root 3 means which coordinates? Z axis. इधर से 20 root 3 में इस पॉइंट में we want to find the magnetic field at this point. And इसके ऊपर करंट कितना जा रहा है? I is equal to 2 by pi amperes. That means this, for this coil, this point is acting like an axis point. Axis only we have to find. Find करो. And turns are given. मतलब आप जो भी फॉर्मूला डालना है into n करने का. फॉर्मूला मानो सात्विक. Mu naught I a square by 2 times of a square plus a. A is a radius. Radius is 20 centimeters. They told you. Solve करो. सेंटीमीटर्स को मीटर्स में कन्वर्ट करना पड़ेगा. And mu naught का formula value 4.10 power of -7.
So 25 mu Tesla.
Micro Tesla, right?
Micro. No, yeah.
Yes, correct. 25 micro Tesla. Formula मालूम है ना? Magnetic field mu naught I a square by 2 times of a square plus x square whole power 3 by 2 times n, because number of turns are, all values are given. A is 20 centimeters, 20 into 10 power minus 2, and x is the distance 20 root 3, that is centimeters है by 100 whole square करने का अगर square है तो, and into 100 करेगा तो you will get the answer as 25 micro Tesla. आया? Calculation छोड़ो, but substitution करके all values are given, right? Just substitute and try to solve. Okay, ठीक है. ये 25 micro Tesla is answer.
Yes, got it.
Two circular current carrying coils are there. Equal number of turns are there, and दोनों same sense में current is flowing in the same point. वो okay, the smaller, this is at d by 2 distance, this is at d distance. He is saying दोनों में same current जा रहा है, I and I. He is trying to find magnetic field at this point P. He is telling the ratio of by bx is how much? So for this coil, this point is acting like axis point, and for this coil, this point is acting like axis point. Divide kar lo. And A is 2R in this case, A is R, X is D by 2 in this case, and D. Substitute.
So 1/2.
Yes, 1 by 2 is answer. साथ ही बोलेंगे आंसर प्रोसेस करो. A is R and distance is D by 2 D.
Sir, got it.
1 by 2 आया. चलो next one. चलो. A circular current carrying coil has a radius R. Okay, the circular coil is there of radius R. Okay, the distance from the center of the coil on the axis where magnetic field induction is. So this is the distance, x distance मान लो. He's telling at this point में the magnetic field at point P is 1/8 value at the center of the coil. 1/8 times that of center of the coil. At that time में he's telling to find the x value is asking. The distance x value is asking. So use the formula of axis का and center का and solve. You'll get the value of x. In terms of R में आएगा, capital R में. So mu naught I A square is nothing but R square by 2 times of A square is nothing but R square plus X square whole for 3 by 2 is 1/8 of center में formula मालूम है ना, coil में center में mu naught by 2 into I by A is nothing but radius R. Now solve, bring all one side and find X.
Sir,
How much?
√3R.
Yes, correct. Solve करो. Mu naught by 2, mu naught by 2 cancel. I cancel. So R square by R square plus X square whole for 3 by 2 is 1/8R. So ये cross multiply करो and solve. You know, 8R cube
Sir, √3R.
आया
Yes.
आपको आपको आया? यू कैन राइट 2r होल क्यूब, ये इसका कितना है आपका श्रीराम?
√3/2.
आया तो 3r आया ना,
Yeah.
तो स्क्वायर, नाउ स्क्वेयरिंग हम बोथ साइड्स किया तो 4r² इज इक्वल टू r² प्लस x², सो 3r² इज इक्वल टू x² एंड x इज इक्वल टू √3r। आया? चलो नेक्स्ट, find the magnetic field at the center of the coil, each coil. Current they given as 1/pi and the radius is 25 centimeters. He's telling find the magnetic field at center of each coil. मतलब एक coil find किया तो बस same है ना, because same radius same distance, so एक coil का find करो। Here magnetic field will be which direction? tell me, मतलब magnetic field will be किसके वजह से रहेगा? दोनों current carrying is there, right? Because
Both.
of this coil also magnetic field will be there, because of this coil also magnetic field is there, right? Okay, now tell me this for this coil this point is acting like center point, and for this coil this point is acting like axis point, so net magnetic field find karo and check the direction clarity, whether plus or minus or we don't know, right? देखो current is coming like this, outwards से ऐसा आ रहा है, current is coming like this, right? So curl the fingers in the direction of current and thumb indicate the direction of magnetic field. So magnetic field in this way B1,
So will it be 0?
huh?
0.
No, not 0, because ये point नजदीक है, ये point दूर है ना, so it's not 0. Okay, now इसका curl the fingers in the direction of current and thumb indicate the direction of magnetic field, so B2. So net magnetic field will be B1 minus B2. Now for this coil this is acting like center point, right? So use karo, center point का formula is mu naught by 2 into I by R. Okay, first coil का हो गया center का minus and for this coil this point is actually axis point, so mu naught I A square means R² by 2 times of A square plus x square is nothing but इसका R√3 whole square, मतलब क्या होगा 3r² whole power 3/2. नेट मैग्नेटिक फील्ड फाइंड करो, टेक कॉमन वगैरह लेके सॉल्व करो। लास्ट में सब्सिट्यूट करो वैल्यूज, फर्स्ट टेक कॉमन वगैरह एंड सॉल्व। सो म्यू नॉट आई बाई 2 कॉमन ले तो 1/r माइनस r² बाई 4r², मतलब 2r होल स्क्वायर होल फोर 3/2, सो कैंसिल, so mu naught I by 2 into 1/r minus r² by 8r cube.
So 6 into 10 power minus 7.
6 into 10 power of, no, no क्या बचेगा? mu naught I by 2 into 8r, 1/r भी बाहर ले लो, so क्या बचेगा 1 minus 1/8, so it is 7/8, so mu naught I by 2r into 7/8. now subscribe values.
So 7 into 10 power minus 7.
Yes, 7 into 10 power minus 7 Tesla. हो गया? Got? Yes. So हम सबसे करो, mu naught का value is 4.10 power of minus 7, I value is given, R value is given, and R को again you have to convert into meters, 25 into 10 power of minus 2. All values are given, इसमें सबसे किया तो you will get an answer as 7 into 10 power of minus 7. this law. आया? चलो next. क्या करो? From the figure shown, find the magnitude and direction of the current loop 2. मतलब करंट चाहिए आपको in the loop 2 में, so that net magnetic field at O is 0. At this point में magnetic field should be 0. So आपको फर्स्ट डायरेक्शन फाइंड करेंगे, किस तरफ रहेगा टेल में. It is going like this current or from top to bottom, so that net magnetic field is 0. So इसका फाइंड कर पहले. It is coming like this, right? तब indicate direction of magnetic field. हाँ, टेल में B1. So उसका करंट कैसे रहेगा? ऐसे रहे तो ही then only the magnetic field get cancelled, right? इधर B2. So current is like this, I2. He's trying to find I2 only. Since net magnetic field is 0, he told, that means I can write B1 is equal to B2. Khatam, no solve karo. For this coil, this acting like axis point, and for this coil, this acting like axis point. No join. And find the value of I2. I1 is given as 8 amperes. So mu naught I a square. ठीक है, last में.
So 4.5 ampere.
आंसर आ गया. कैसा? क्या किया?
So the same, they equated.
इक्वेट करो, सॉल्व करो अच्छे से.
Solved that I got 4.2 ampere.
सर्चिंग समवेयर तमाश नहीं आएगा. करो. 4.5 is the answer, but right. So mu naught first coil के वजह से this point actually axis point, right? Mu naught I is 8 ampere into a square. A square means 3 square by 2 times of a square plus x square whole power 3 by 2, right? Is equal to इसका क्या होगा? Because equating, right? सेंटीमीटर से करने की जरूरत नहीं है. Mu naught into I. Oh, I is I2, right? No. Square I a square, right? I a square is 4 square by 2 times of 4 square plus 3 square whole power 3 by 2. If you see bottom में 3 square plus 4 square is cancel है, mu naught cancel है. So कितना होगा? 16 2 जा and 9 by 2 is 4.5 amperes. Okay? चल next. Now circular current loop as a magnetic dipole. आपको मैग्नेटिक डाइपोल बोल के आपको इवन नेक्स्ट चैप्टर में भी आएगा. मैग्नेटिक डाइपोल, दैट मींस ए करंट कैरिंग कॉइल will behave like a magnetic dipole. Dipole means 2 poles, north pole, south pole. Any current carrying coil will behave like a dipole. Okay, but with very far distance में. Okay, we will see that. We will derive that one. देखो, suppose मान लो you have a coil of radius A, x distance दूर में axis point, you know. What is the formula axis point का? बोलो श्रीराम, अभी तक फॉर्मूला आ गया? याद है ना? बोलो. mu naught
I a square divided by 2 a square plus x square whole power 3 by 2.
x square whole power 3 by 2. Right? This is the axis point. Now देखो, here if x is much greater than a, then only this will act like a dipole. We will prove dipole जैसा act होगा. Okay. So x is much greater than means a distance is much greater than a. मतलब a is very small. किसको neglect करेंगे? A या x का? Which one we have to neglect? A, right? So axis का is equal to mu naught I a square by a square को निकल जाएगा 2 times of x square whole power x cube आएगा ना, 2x cube, right? इसका comparison में this is small, that's why we are removing. Okay, comparison से. Okay, now इसको थोड़ा एक फॉर्मूला जैसा लेके आएंगे. देखो, I am doing into 2 pi by 2 pi multiplying divided by 2 pi. Okay, so B at axis is equal to mu naught 2 times of pi a square I by 2x cube into 2 pi. 2x cube into 2 pi. Okay. Now tell me, मैं क्या करूंगा? ये pi a square is what? Pi a square is nothing but
area.
area. So मैं क्या करूंगा? 4 pi x cube is right. now करो. So b at axis is equal to mu naught by 2 into 2 4 pi. Okay. Into 2 times of I a. देखो I into area of a circular coil by x cube. Right? 2ia by x cube. Okay. There is a magnetic moment we represent as m. M का formula है ia. Magnetic moment, whenever for current carrying wire, magnetic moment is nothing but ia. So if I substitute I के जगह में m, b at axis where x is much greater than a. So mu naught by 4 pi into 2m by x cube. ये फॉर्मूला देखो, आपको m के जगह में IA लगाए तो ये आएगा. सो ये रिमेंबर करने का, आपको ये भी आपको रिमेंबर करने का. ओके, then why the current loop act like a magnetic dipole from this means, you remember dipole in first chapter में? Anybody tell the formula of axis dipole के वजह से two charges minus q plus q separated by distance r, center से r distance दूर में, what is the magnetic field? Electrostatics. उधर डबल रहेगा, इसमें अदर इक्वेटर में आप P is the dipole moment.
Sir,
2k
2k
shortcut बोल रहा हूँ.
2k
P
short
by
2k p by a cube.
x cube, 2 r cube, right? 2 kp by x cube. याद है ना? इक्वेटर में आधा रहेगा, right? इधर देखो, k is constant, right? देखो 2 km by x cube. That means the dipole जैसा act हो रहा है. Magnetic field also it is acting like, मतलब a current carrying coil में when x is much greater than a, then only this is happening. It is acting like dipole. Okay, and उसका magnetic field कितना है? mu naught by 4 pi into 2m by x cube. M is nothing but any magnetic moment, any current carrying coil का magnetic moment is I into a. I into a. A is a area vector. So directly you can use the formula in this case में. They will mention question में x is much greater than a बोल के. Or they'll give x is meters, this is 0.01 millimeters ऐसा. So we can know that x is much greater than a. Shortcut use करेंगे that. It's acting like a dipole. Dipole means north pole, south pole. Okay.
So can we use this dipole formula when a is not that small?
No, we can't use, because we cannot neglect right here. So that time we can't use. Okay, this is only when this is acting like dipole, only when the x is much greater than a. Okay.
So what's the direction?
Direction क्या है? Magnetic moment is from always from, देखो, minus q plus q separated by distance, right? L and L.
Yeah.
So इसका direction क्या होगा? Tell me.
South, like negative to positive.
Negative positive from south to north.
South to north.
Minus q is acting like south pole. Okay. चलो. So current loop always behave like a magnetic dipole, only when x is much greater than a. I'll send the formula sheet today. कबीर चलो ना करो. देखो, here two coils are there. Q, this Q point origin से कितना दूर है? 0.3 meters दूर में है. And 0.4 meters में the P coil is there. Okay. इसके वजह से they told the magnetic field is downwards. इसके वजह से magnetic field is like this towards BP and BQ, and दोनों का magnetic needle लगाने से, compass लगाने से it is showing certain angle theta. Okay, he is telling the deflection theta is how much when x is much greater than r. Okay, so in this case में he is telling to find the deflection theta. तो कैसा है
So
theta?
shouldn't the direction
हाँ,
of
डायरेक्शन
P
चेंज होने
be,
का,
yeah.
ये ऐसा रहने का थोड़ा, बिकॉज ये उल्टा हो रहा है ना.
Okay, so we have to change the direction of P or like BP
एक्चुअली
or
ये वाला उल्टा ये होने का, ये वाला ऐसा नहीं, इसको तो सेम
okay.
है, राइट? देखो
Yeah, by
इसका तो
same.
सेम है. हाँ, दिस विल बी चेंज.
Yeah.
ओके,
So
नाउ
BP is that side only, no? BP
इट
is
शुड बी
that
लाइक,
side.
राइट? बाय दिस मींस ओके, ऐसा रहेगा,
Yeah.
ऐसा. Now he has given one thing that the current is 16 amperes in P coil. P coil में 16 amperes current is flowing, and इसमें कितना current flow है? 9√3 amperes current flow. As seen from the origin, the cross section is given as AP by AQ is given as 4:3. Deflection theta. Okay, theta के लिए we can use trigonometry. What is tan theta? Opposite by
BQ.
adjacent. Opposite nothing but BQ by BP. खत्म. Find करो no. मतलब this, for this circular current carrying coil, this acting like a axis point, and for this one is acting like a axis point. दोनों divide करो, आ जाएगा. Try to find theta. And which formula we have to use? Axis point ka we have to use the shortcut formula, which I told, right? 2 wala mu naught by 4 pi into 2m by x cube wala. M is nothing but IA. So tan theta is equal to mu naught by 4 pi into 2 times of m is nothing but IA by x cube. Okay, ये किसका आपको Q का, राइट? Q का एरिया, Q का करंट, हाँ, बाई म्यू नॉट बाई 4 पाई इंटू 2IA बाई एक्स क्यूब. किसका? ये P का. नो कैंसिल करो, व्हाट आर द थिंग्स, म्यू नॉट बाई 4 पाई कैंसिल एंड फाइंड थीटा.
So 60 degrees.
Yeah, 60 degrees. आया आपको? सॉल्व करो. आ गया? यस. सीधा आया ना? 2 डिवाइड कैंसिल. सभी करंट इज गिवन, इसका करंट इज गिवन, इसका करंट इज गिवन, एरिया इज गिवन, रेशियो आल्सो गिवन, and x का distance also given 0.3, this is 0.4. Just substitute the value, answer is 60 degrees. Chalo. No. Next one is Ampere circuit law. We finished circular wire class. Circular wire ka done. I told you magnetism chapter में we are having only 3 shapes: straight wire, circular wire, solenoid and toroid. They taught, right? Toroid भी deal करेंगे. Toroid they taught, हाँ, toroid भी deal करेंगे actually. Okay, चलो. Ampere circuit law क्या है? We'll see. First write the definition of Ampere circuit law. The line integration of magnetic field along the closed path is equal to mu naught times of total current enclosed by that path. देखो, closed integral B dot dl is equal to mu naught times of I inside. ये एम्पेयर सर्क्यूट लॉ it is a shortcut to find the magnetic field. See, normally magnetic field अभी तक कैसा find करता था? By using Biot-Savart's law. Biot-Savart's law use करके we used to find magnetic field integration करके. But without integration वगैरह में directly we can get magnetic field by using this shortcut. After so many years के बाद they found this one. A line integration करके mu naught times of I inside. We'll take the example. कैसा क्या है? We'll see. हो गया? चलो. No. Find the magnetic field due to current I coming out of the paper at a point P. Okay. Suppose मान लो there is a current carrying coil. It's coming outwards. ओके, जनरल प्रोसीजर बोल रहा हूँ, बाद में एप्लीकेशन देखेंगे, उसमें डिटेल में सॉल्व करेंगे. तो ओके, इस करंट कैरिंग कॉइल की वजह से इस पॉइंट में आई वांट टू फाइंड मैग्नेटिक फील्ड एट दिस पॉइंट पी. ओके, करंट कैरिंग वायर इज कमिंग टुवर्ड्स यू. आई वांट टू फाइंड मैग्नेटिक फील्ड एट दिस पॉइंट पी. ओके, सो क्या करेंगे? फर्स्ट स्टेप बाय स्टेप अंडरस्टैंड करो. एम्पियर सर्किट लॉ बहुत अच्छा है. ओके, सो फर्स्ट स्टेप इज व्हाट? Wherever you want to find the magnetic field, you try to draw an imaginary surface. And that is a 2D surface. That should be 2D surface. Gauss law में आपको क्या है? 3D surface use करता था. So we have to use the 2D surface. Okay, and write the formula. Closed integral B dot dl is equal to mu naught times of I inside. Okay, so wherever you want to find the magnetic field, first try to make a Ampere loop that should be symmetric about this current. And that Ampere loop can be any shape. Circular हो, square हो, rectangle, anything. Okay. Now आपको इधर क्या क्या चाहिए? B भी चाहिए, magnetic field चाहिए, DL चाहिए, current inside भी, सब कुछ चाहिए. Okay. Next, second step. Second step क्या है? Put the loop direction. Loop direction लगाओ. Either clockwise लगा सकते हैं और anti clockwise लगा सकते हैं. Okay. So मैं anti clockwise लगा रहा हूँ. Loop direction. It can be any direction. Okay. लूप डायरेक्शन लगा दिया. सो फर्स्ट स्टेप क्या है? वेयर एवर यू वांट टू ट्राई टू फाइंड द मैग्नेटिक फील्ड एट दैट पॉइंट पी, ट्राई टू मेक एन इमेजिनरी लूप एंड टेक द लूप डायरेक्शन. ओके, लूप डायरेक्शन ले लिया. नाउ आपको बी चाहिए, डीएल चाहिए. राइट, बी कैसे आएगा? यू नो, अप्लाई राइट हैंड थंब रूल. किस तरफ रहेगा? थंब इंडिकेट्स द डायरेक्शन ऑफ करंट एंड कर्ल्ड फिंगर्स इंडिकेट डायरेक्शन ऑफ मैग्नेटिक फील्ड. राइट, इट इज एंटी क्लॉकवाइज. राइट, देखो, थंब इंडिकेट डायरेक्शन ऑफ करंट, कर्ल्ड फिंगर्स इंडिकेट डायरेक्शन ऑफ मैग्नेटिक फील्ड. So magnetic field is like this, right? Because आपको क्या चाहिए? When you do the dot product, A, B, cos theta, angle चाहिए ना? So for that के लिए आपको magnetic field दिखाने का, DL भी दिखाने का. That is the second step. Okay, first step में दे डाला, second step में loop direction, third में magnetic field का direction लगाया. And DL vector, DL है ना? DL vector should be in the direction of loop direction. लूप डायरेक्शन में डाल दो. तो लूप डायरेक्शन एंटी क्लॉकवाइज है ना, उसी डायरेक्शन में डीएल वेक्टर इज देयर, उसी डायरेक्शन में डीएल वेक्टर एंड उसी डायरेक्शन में डीएल वेक्टर. राइट, नाउ एंगल आ गया. एंगल बिटवीन डीएल वेक्टर एंड मैग्नेटिक फील्ड इज हाउ मच? दोनों सेम डायरेक्शन है, 0. नाउ यू टेल मी, दैट मींस क्लोज्ड इंटीग्रल B डॉट dl इज इक्वल टू म्यू नॉट टाइम्स ऑफ, इस लूप के अंदर में कितना करंट है, इस लूप के अंदर में कितना करंट है, वो दैट आई इनसाइड जगह में लिखने का. हियर ओनली वन करंट इज देयर, आई. सो आई लिख के, मतलब इसको सॉल्व करके मैग्नेटिक फील्ड आ जाएगा. दैट विल डू इन एप्लीकेशंस में. सो जनरल प्रोसीजर बोल रहा हूँ, सीधा अंडरस्टैंडिंग. ये बहुत इंपॉर्टेंट है. ये आगे तो देन ओनली एप्लीकेशंस वी कैन नो. सो फर्स्ट स्टेप इज व्हाट? वेयर एवर यू वांट टू फाइंड द मैग्नेटिक फील्ड, ड्रॉ एन इमेजिनरी लूप. सेकंड स्टेप में इंडिकेट द लूप डायरेक्शन, either clockwise or anti-clockwise. देखो, अगर clockwise लगाए तो DL and B will be 180 degrees. एंड करंट नेगेटिव आएगा, सो माइनस माइनस गेट कैंसिल, अगेन सेम आंसर ही आएगा. तो आप कैसे भी लगो, लूप डायरेक्शन इंडिकेट करो सेकंड स्टेप में. थर्ड स्टेप में मैग्नेटिक फील्ड बाय यूजिंग राइट हैंड थंब रूल यू कैन यूज द फाइंड द मैग्नेटिक फील्ड and dl vector and you have to solve the magnetic field. This is a shortcut to find the magnetic field. आया? चलो. Now suppose मान लो you have two currents. I want to find the magnetic field at this point P. Okay. So first step is what I told you. Wherever you want to find the magnetic field, just form the imaginary loop that should be symmetric about this axis. Okay. Now formula डालो. Closed integral B dot dl is equal to mu naught times of I inside. Mu naught times of I inside. Okay. Chalo. Now I inside is which one is positive, which one is negative, we have to know. Because we don't know which both on different directions, right? एक positive एक negative है. Second step is what? Indicate the loop direction. आप कैसे भी loop direction ले लो. I am taking anti-clockwise. Loop direction. And to understand sign convention, आपको क्या करने का? Curl the fingers in the direction of loop. And जो भी direction correct दिखा रहा है ना, that is nothing but positive direction. Okay. So for positive negative के लिए क्या करने का? Loop direction लेके curl the fingers in the direction of the loop and thumb indicates the positive direction. Which one is positive now? Which one is positive? I1 is positive. And which one is negative? I2 is negative. Okay. So क्या करने वाले देखो. So first we choose the loop direction anti-clockwise. Second step, curl the right hand fingers along the chosen direction of the loop. Thumb points the positive direction. Thumb points the positive direction. Therefore, B dot dl is equal to mu naught times of I inside. I inside wala which is positive, this is positive, right? I1 minus I2. And same way magnetic field, since I took this as positive, क्या है? Thumb indicate the direction of current and curled fingers indicate direction of magnetic field, right? So same way magnetic field is like this. And dl vector will be in the direction of the loop. And आपको आगे का solve करने वाला है. So now we are not solving magnetic field. Just to understand I inside की जगह में I inside कैसा आ रहा है बोल के we are trying to find. From this we can find the magnetic field easily. Okay. So generally एक current आए तो चलो easy है positive लेने का. वो direction में ले वही direction में we are taking the loop direction also. It is easy for us. Okay. चलो. Now इसका एक एक का application देखेंगे कैसा how to find the magnetic field and we will solve the questions. Okay. चलो हो गया. Copied. See, I'm done. Okay. चलो. Application देखेंगे. Using Ampere Circuital Law to find the magnetic field due to straight current carrying wire, infinite wire. Formula याद है ना? Infinite current carrying wire के वजह से magnetic field कितना है? mu naught by
2 pi into
4
I
pi.
by.
mu naught by 4 pi into मतलब कैंसिल मत करो. See,
Okay.
always mu naught by 4 पे रहने दो. mu naught by 4 pi into 2I by A. That is the thing. Always 2. समझ में आया श्रीराम? Formula याद है ना? mu naught by 4 pi into I by A. Okay, chalo. Now देखो, by using Ampere Circuital Law we are solving now. Okay, so this is the infinite current carrying wire. Infinite current carrying wire. इधर से A distance दूर में I want to find the magnetic field at this point P. I want to find the magnetic field at this point P by using Ampere Circuital Law. Okay. Shortcut. अगर normally Biot law बोलते तो we should take the small dl element के वजह से we used to calculate that. But here what we are doing simply by using Ampere Circuital Law we are trying to find the magnetic field. Okay. First step क्या है? We have to draw an imaginary loop that should pass through this point P. We are drawing the imaginary loop that is passing through the point P. Okay. And write the formula. Closed integral B dot dl is equal to mu naught times of I inside. Mu naught times of I inside. Okay, understood? Okay, now if you see the current, it is coming upwards, right? A current carrying wire top view में देखने से current is coming upwards, right? So मैं क्या करूंगा इसको थोड़ा simplified model में देखो the current is coming upwards ऐसे लिख रहा हूँ ड्रॉ कर रहा हूँ ऐसा top view. And this is the Ampere's loop. देखो, this is the Ampere's loop. So that easy for me to apply the Ampere Circuital Law. देखो फ्रॉम टॉप व्यू में देखने से करंट इज कमिंग अपवर्ड्स, सो अपवर्ड्स को वन करंट ओनली इज देयर, राइट? आई एम पुटिंग डॉट आई एंड दिस इज एम्पेयर्स लूप फ्रॉम टॉप व्यू, दिस इज द टॉप व्यू. Okay. Now next step क्या है? Loop direction. I choose anti-clockwise. And thumb indicates the direction of current and curled fingers indicate the direction of magnetic field. Magnetic field भी represent कर रहा हूँ. B, 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 B. And DL should be taken in the direction of loop direction only. Loop direction में DL, 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 DL. Now angle between B and DL is 0. I'm substituting this one. Closed integral B DL cos 0 is equal to mu naught times of I inside. इस अंदर लूप के अंदर में एक ही करंट है I. Okay. And cos 0 is 1. Magnetic field is constant, right? Everywhere. Magnetic field is coming outside. And what is DL, 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 DL of the circumference? The circumference of circle. That is,
2πa.
इसका distance is A मान लो. और कितना है? 2 pi A, right? Because A है ना loop इधर से ये वाला A. So it is mu naught times of I. So B is equal to mu naught by 2 pi into I by A. I am multiplying divided with 2. So that आपको फॉर्मूला मैच हो गया mu naught by 4 pi into I by A, 2I by A. This is the formula magnetic field for a current carrying wire. Very simple है, अंडरस्टैंड. इसका एप्लीकेशन आने वाला है. इफ यू डोंट अंडरस्टैंड बीच में क्लास हो जाएगा. mu naught by 4 pi into 2I by A. हो गया? Yes. चलो. Now second application. Magnetic field due to hollow cylindrical wire. And current hollow बोलते inside तो कुछ current नहीं है. Only current will be flowing on the surface only. Right? इसमें एक hollow cylindrical wire is there. See, whenever they say wire, it is a cylindrical wire only. Current is flowing in the surface only. And इसका radius है R, capital R. I want to find the magnetic field outside, surface, and inside by using Ampere Circuital Law and draw the graph. Okay, and draw the graph. That is our aim to find thing. Okay. So a hollow है. Hollow के बारे में देखेंगे. Then we'll go for the cylindrical. Okay. Next. Outside point. R is greater than R. Capital R is nothing but the radius of the hollow sphere, hollow cylinder. इसको बाहर के we are trying to find. देखो, a cylindrical wire है, radius R है. इधर से R distance दूर में I want to find the magnetic field. Smaller distance में I want to find the magnetic field. So first step, you form the imaginary loop, 2D shape में. Okay, it's imaginary. Now write the formula also. Closed integral B dot DL is equal to mu naught times of I inside. Okay. Here we have to understand आपका शॉर्टकट मेथड में फॉर्म वी हैव टू फाइंड, राइट? ए बड़ा सा है, छोटा डायग्राम ड्रॉ कर रहा है. वो छोटा डायग्राम देखो. इफ यू सी इन द टॉप व्यू, द करंट इधर चारों तरफ है, चारों तरफ करंट आएगा. बीच में तो नहीं है ना, बीच में तो नहीं है. ओनली फ्रॉम टॉप व्यू से ओनली हियर 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 करंट इज कमिंग, राइट? टॉप व्यू में से. So if I draw the shortcut method, the current is like this. The current, okay, current is flowing like this. And ampere loop ये draw कर रहा हूँ. This is ampere loop. And इधर से कितना distance है? Small distance. So center से is a point P, right? समझ आ रहा है? टॉप व्यू में से द करंट्स आर कमिंग लाइक दिस, सरफेस में ओनली, इनसाइड नहीं है, ये हॉलो है. ओके. हाँ, नाउ ट्राई अप्लाई बायोट सी एम्पेयर सर्किट लॉ ट्राई करो, अप्लाई. फर्स्ट इंडिकेट द लूप डायरेक्शन एंटी क्लॉकवाइज ले रहा हूँ. एंड मैग्नेटिक फील्ड तो देखो करंट इज कमिंग आउटवर्ड साइड, मैग्नेटिक फील्ड तो ऐसा है, सेम थिंग. And DL should be taken in the loop direction. ओके, एंड आई इनसाइड इज आई ओनली, आई इनसाइड फाइंड करो कितना आएगा आंसर बोलो. Like this, any shape they can give, always try to follow Ampere circuit law. For cylindrical, no need of by adding the formula. Just so कितना होगा? Closed integral B dl is equal to mu naught times of, इस लूप के अंदर में I inside is I only, B is coming outside, dl मिल गए तो टोटल सर्कमफेरेंस ऑफ सर्किल कितना है 2 pi r is equal to mu naught I. So B is equal to mu naught by 2 pi into I by r. I am multiplying and dividing it 2 so that you can remember like formula also. Mu naught by 4 pi into 2I by r. देखो, this is like infinite wire only. Cylindrical wire is nothing but infinite wire only, hollow wala, 2I by r. That means here understand B is inversely proportional to r in the outside. B is inversely proportional to r. Can you tell me on surface में कितना होगा? When the point P is on the surface, smaller will become capital only. Substitute surface में mu naught by 4 pi into 2I by capital. Right, surface में. Okay, चलो now inside करो देखते हैं. I want to find magnetic field at this point P, which is r distance of. Try करो कितना आएगा. Apply Ampere circuit law and try to find magnetic field.
0.
0. Good. So closed integral B dot dl is equal to mu naught times of I inside. Sriram, इसके अंदर में there is no current because current is flowing on the surface only. So since I inside is 0, the magnetic field is 0. So B is 0 since I inside is 0. Now इधर inside 0 है, surface में increase हुआ, बाहर inverse relation, बाहर से inverse relation जैसा. Okay, so if I draw the graph, देखो inside is 0, surface में maximum हुआ, बाद में outside is inverse relation. Inverse relation है ना. By seeing you understand it is a hollow wire, hollow cylindrical wire. If they say hollow wire also same as cylindrical wire only. नेक्स्ट में क्या करने वाले हैं? नेक्स्ट में we'll see the solid cylinder curve we'll see and then we'll go for a solenoid. solenoid का भी करने वाला है, टॉरॉइड भी करेंगे कल, मैग्नेटिज्म का ट्राई टू डू, and then we'll start force.